So we know that has to be 49 because we know that the square root of 49 is equal to 7. So there's the first step that we always do when you're solving equations that have a radical, is we use this step that says square both sides of the equation. And that's that intuitive step of, if you just think about it for a second, of knowing that if my answer has to be 7, then I know that the square root of 49 is equal to 7. So that's how we always start with these. We remove that square root, and now I'm left with x plus 1 is equal to 49. Subtract 1 from each side, and I get x is equal to 48. But the first step with this is always to square both sides. And it has to be the entire side of the equation. You cannot square the terms. Now, we don't want to do this. And the reason we don't want to do this is, do you see how everything inside this is in parentheses? And this is quantity squared? If I did it this way, this would mean I would have to FOIL all of this out. And I really don't want to FOIL all of that out. We can, but I really don't want to. So I'm not going to do it this way to start. Instead, I'm going to take this away and take this away. And instead, what I want to do with this is subtract 2 from both sides. And this was an 8. And that leaves me with this much nicer problem to go ahead and deal with, which is the square root of 5x plus 6 is equal to positive 6. Now I want to go through and square both sides. So this leaves me with 5x plus 6 is equal to 36. I want to go ahead and subtract 6 from both sides. 5x is equal to 30. I divide 5 from both sides, and I get x is equal to 6. Now, we always need to check these, and you're going to see why in the next section. So to check this, is 5 times x, which we just found was 6, plus 6, or 30 plus 6. Yes, the square root of 36 does equal to 6. So you do want to always check these. Now, it doesn't matter the value that you have as the index. If it was the cubed root of 6x was equal to negative 4, now we can do this. Now, 4 times 4 is 16. 16 times 4 gives us the cubed root of 4. So I know that 60, oops, what am I writing? I know that the cubed root of 64 is equal to 4. I also know that negative 4 times negative 4 times negative 4 will equal a negative 64. So I also know that the cubed root of negative 64 is going to equal a negative 4. So negatives are all right as long as this index is odd. Then it's okay to have that negative there. But it's still going to be the same first step. I still want to go ahead and cube both sides. Just watch your signs when you're doing this. You get 6x is equal to, And again, we did this before. Negative 4 to the third power is negative 64. And I just divide both sides by 6. And that doesn't go evenly, but you want to go ahead and reduce that. That just gives us, they're both divisible by 2. So that gives us negative 32 over 3 for our final answer there. Whenever the entire radical is being squared, it just equals everything that is underneath it. So all of this over here on this side is just equal to 13 minus x. But when I square this side over here, that means you have to write it out twice and FOIL it. Now, that gives me 13 minus x on the left, x times x is equal to x squared. X times negative 1 is equal to negative x. Negative 1 times x gives me another negative x. And then finally, negative 1 times negative 1 gives me a positive 1. Now I want to go ahead and combine like terms. The negative and the negatives do not cancel out. They add together. That's negative 1 minus 1. So that ends up giving me negative 2x plus 1. Now, 3 I have to solve. But if you notice, this is an x squared piece here, correct? So what that means is this is not solving a regular equation. This is solving a quadratic equation. So what that means is I have to, in order to solve this, I have a few different steps. I have to first set the equation all equal to 0. And then I have to factor before I can find x. So the way I'm going to do that is I'm going to subtract 13 from both sides and then add x. Over here on this side it all becomes 0. And then I bring my x squared down. Negative 2 plus 1 just gives me minus 1. X minus 12. All that's equal to 0, and I just can't stand it that way, so I'm just going to move that 0 and rewrite it. All right, so a quick review of factoring. This is a times c over b. So that's going to be negative 12 over negative 1. So I take a look at the factors of 12. One of them has to be positive, one of them has to be negative. Those factors of 12 are 1 and 12, 2 and 6, 3 and 4. So I want two numbers that multiply to equal negative 12, but add or subtract to equal negative 1. And those two numbers are going to be 3 and 4, but I want it to be a positive 3 and a negative 4. And when we square both of the sides, we just get 2x minus 3 on the left. And over here, I have to make sure I FOIL that out. So that leaves me with 2x minus 3 is equal to 9 minus 3x plus x squared. Remember, when it's a perfect square trinomial, it's always going to be twice that middle term when I combine my like terms. So then I get 2x minus 3 is equal to 9 minus 6x plus x squared. And I'm going to I do these both in the same step. I'm going to add 3 and subtract 2x, which gives me a 0 on this side. And over here, I'm left with 12 minus 8x plus x squared. And now I'm just going to go ahead and move all of that up and reorganize it. So now I'm left with x squared minus 8x plus 12 is equal to 0. I'm looking for the factors of 12 that equal a negative 8. All of the factors of 12, 1 times 12, 2 times 6. So we're going to use 2 and negative 6 because those two will add up to give me my negative 8. So then it's factored to be x minus 2 times x minus 6 is equal to 0. And x minus 2 is equal to 0. So x may equal 2, and x minus 6 is equal to 0, so x is equal to 6. Now notice, it's not because one of them is negative and one of them is positive that we're throwing it out. You always have to go back to the original equation. And in the original equation, we didn't have those squareds there. So this was our original equation that we're going to go ahead and plug it into. So let's go ahead and start with x is equal to 2. That gives us 2 times 2 minus 3. Does that equal 3 minus 2? So underneath this radical, 2 times 2 is 4 minus 3. So that's the square root of 1 is equal to 1. So that one works. Now, don't automatically throw the next one out. Let's go ahead and check it. So the next one here is 2 times 6 minus 3. Does that equal to 3 minus 6? And as soon as you see this over here, you know that's going to equal to a negative 3, so we're going to toss that one out. But just to do the work, 6 times 2 is 12 minus 3, and the square root of 9 does not equal negative 3, so you have to cancel that one out. Looks good? Okay. So it's kind of, it's nice having just two of you here, so you guys get chances to ask more questions.